In this lesson, we're going to kind of go back to solving systems of equations, but we're going to look at some different things now that you worked with quadratics. We're going to start working with circles, ellipses, hyperbolas a little bit more, which you've seen before. But we're going to take those and we're going to kind of find intersection points. So we're going to revisit different methods right now, how to solve systems. There are three different ways. One, as you can guess, there's a graph here. So the first way is by graphing. We can also solve by substitution. And finally, we can solve by something called elimination. Or sometimes we refer to that as the addition method. So you may have heard of it as one or the other, or interchangeably as both. So you should think of it as both of those. All right, so this one says solve the system, then graph it, and graph it on the same axes. So first, we're actually just going to graph this one. So here we've got y equals our first equation, y equals x squared minus 1. We should recognize this as a quadratic right away. That makes a parabola. Now there's two ways you can do this. Hey, you can say one, well, hey, I know the vertex is going to be at 0, -1, because there's nothing with the x, and there's a -1 outside. Or you can use that x equals the opposite of b over 2a. So we get x equals, there's no b, so x equals 0. When you put 0 in, we get -1. So 0, -1, so we're going to go over to 0. And we're going to go down 1. So 0, -1. Alright, so now we need to say, you can use the pattern, you can use the table, you can just plot some points. Again, if that's the vertex, we're going to go up 1 over 1 if you're using that quadratic pattern, up 3 over 1. And then we're going to mirror that on the other side. So back 1, up 1, up 3, over 1. And then again, we can keep going. You can go up 5 over 1, but I'm going to call it a day at those, and I'm going to connect my graph. Alright, so now we got to graph the second one. Right here, we should realize, hey, this is going to be a linear function. However, we need to get y alone. So x plus y equals 1. Y equals -x plus 1. So we're going to go up 1. That's our y-intercept. We're going to go down 1 over 1. Intersect. Down 1 over 1. Down 1 over 1. Down 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. So realize we had another point of intersection over here. So again, connect your graph. You should be using a straight edge because Mr. Milliken does not. Doesn't mean you shouldn't, because your graph should look a lot nicer than that does. Alright, well, what is that point? -2, 3. So we intersect at -2, 3 and at 1, 0. So those right here are your solutions. If you recall from graphing earlier in earlier chapters, the intersection points are the solutions to the equation. Alright, so now let's talk about substitution. So solving a system by substitution. So what does substitution mean? Well, it means when, well, we're going to use this when you have either an x equals / y equals, or even an x squared equals, or a y squared equals. When those can be obtained. Now, when those can be obtained, then you want to use that to substitute. So like, hey, if you look at these equations, I could probably isolate an x squared. Like here, if I add y, I get x squared equals y plus 5. Well, if x squared equals y plus 5, I want to take y plus 5 and put it in x squared in the original equation, the first one. So then I have y plus 5 plus y squared plus 2y equals 3. Now I can combine and solve this. So let's do y squared first, plus 3y plus 5 equals 3. Subtract 3, y squared plus 3y plus 2 equals 0. And now it's just simple factoring. Y plus 2, y plus 1 equals 0. So y equals negative 2, y equals negative 1. Well, we need to take those and we need to solve for what x would be. So I'm going to take y equals negative 2, and I'm going to take y equals negative 1, and solve. So y equals negative 2. Let's put that into x squared equals y plus 5. So x squared equals negative 2 plus 5. X squared equals 3. Take square root. X equals plus root 3. X equals minus root 3. So we've got the solutions root 3, negative 2, and negative root 3, negative 2. Now we got to find our solutions for negative 1. So x squared equals negative 1 plus 5. X squared equals 4. Square root, x equals 2. X equals negative 2. I split these so that you can see that there's two solutions paired with negative 1. So then you have negative 1, oops, you've got 2, negative 1. You want to be careful where you're putting x and y. And negative 2, negative 1. And then here are the four solutions to that equation. Alright, so now we've got a few more methods here. We have to solve some by elimination, or the addition method. So when you want to use this is pretty much when you can easily cancel out terms. So here, look, we've got opposites of each other. We've got negative y and positive y. Well, if you start out with opposites of each other, add them together. You get 2x squared equals 5 plus 7, we get 12. Divide by 2, x squared equals 6. Square root, x equals plus root 6. X equals negative root 6. So now we got to go and find their pairs. So let's take this one off to the side, and we're going to take this one over here. I'm going to go ahead and plug this back in to the second equation. So square root of 6 squared plus y squared equals 7. 6 plus y squared equals 7. Minus 6, y squared equals 1. So y equals 1, y equals negative 1. Oops, sorry. So two solutions we yield from there. We get square root of 6, 1, and we get square root of 6, square root of 6, negative 1. Right? And then we got to use negative square root of 6. So negative square root of 6 squared plus y squared equals 7. Again, it's still going to be 6 squared equals, and we realize, oh hey, this is the same. So you don't even have to do the work. Y equals 1, y equals negative 1. And then we've got negative root 6, 1, and we've got negative root 6, negative 1. And again, we have four solutions here. Alright, now this is kind of the confusing one. When you have a bunch of these, you want to say like, hey, well, how do I cancel them out? You can either choose the x's, you can choose the y's. I'm going to go ahead, I'm going to multiply this equation by negative 2, so then I can cancel out the x's. So I'm going to rewrite this as 2 over x plus 1 over y equals 1/5. And I've got negative 2 over x plus 6 over y equals negative 2 over 3. So again, those are the same, they cancel. 1 plus 6, I've got 7 over y equals 1/5 minus 2/3. So 1/5 minus 2/3. Well, if we multiply by 3, we get here, we get 3/15 minus, multiply by 5, 10/15. So we got negative 7/15. 7 over y equals negative 7/15. And we've got negative 7y equals 7 times 15. Well, you could have realized, hey, those would cancel out. So y equals negative 15. Now you got to go ahead and solve for x. So let's take the first equation. We're going to put y equals 15 into that equation. So 2 over x equals 1 over negative 15, plus equals 1/5. Well, 2 over x equals 1/5 plus 1/15. Making like terms here, well, I got to multiply by 3, that's going to be 3/15. So we end up with what? 4/15. So 2 over x equals 4/15. 30 equals 4x. Divide by 4, divide by 4. X equals, 15 over 2. So again, put it back as a coordinate. Got 15 over 2, negative 15. So 15 over 2, negative 15. And that is the answer to that equation there. Alright, and then one last example. Now this should be pretty familiar because we just worked with logarithms. Well, I got a y equals and a y equals. Set them equal to each other. So let's do log 2 of x plus 28 equals 3 plus log 2 of x. So now remember, if we have logarithms, we are kind of like, hey, same base, we want to do 1 to 1. But since we have this plus 3 in front, we can't. So get the logs to one side. So log 2 of x minus log 2 of x. So let's write that. Log 2 x plus 28 minus log 2 of x equals 3. Well, remember, subtraction really means division. So now I have the logarithm base 2 of x plus 28 over x equals 3. We have a single logarithm left, so let's change this around. 2 to the third power equals x plus 28 over x. 2 to the third equals x plus 28 over x. So I'm going to move this up here now. We've got 8 equals x plus 28 over x. Cross multiply. 8x equals x plus 28. Subtract x, subtract x. 7x equals 28. Divide, divide. X equals 4. Well, now we got to solve, though. So choose one of your logarithms to put it back in. Let's see. I'm going to choose the second one. So again, I'm going to move here. X equals 4. So y equals 3 plus log 2 of 4. Well, remember, log 2 of 4, I can rewrite 4 as 2 squared. So log 2 goes away. I've got 3 plus 2 equals y. Y equals 5. And write it as a point. 4, 5. And that is your solution to that problem. So now, after having done this, you should try the remaining 3 problems on this worksheet on your own. Or sorry, the remaining 2 problems on the worksheet on your own. That would be these 2 problems here. So solving by substitution, solving by elimination. And then we'll start during class tomorrow.